Hello beautiful people and welcome. In today's video we are discussing how to simplify rational expressions. Now the word rational is just a very fancy way to say fraction with a polynomial on top and a polynomial on the bottom. Now sometimes that fraction will be in factored form, sometimes that fraction will not be in factored form, and our goal is to simplify this fraction. So let's talk about fractions. So when you have a fraction, something like 6 over 9, what we typically do, we're like, oh, well, we can divide by 3 on top and 3 on bottom because 3 goes into 6 and 3 goes into 9. So we get a 2 and we get a 3 in the denominator. But why does that actually work? Well, in reality, I'm going to put this kind of separate. In reality, what happens is we factor out 3 and then we divide. So we have 6 over 9, and we're going to list out its factors. So we have a 2 times 3, and we have a 3 times 3. And when we factor 6 and we factor 9, we notice that we have a 3 on top and a 3 on the bottom. This only works with multiplication. If you have addition and subtraction, this will not work. So that means we have a 2 divided by 3 times a 3 divided by 3. Well, a 3 divided by 3 is just 1. So here's your big 1. So that means I have a 2 divided by 3 times 1 over 1, which means 2 divided by 3. And I'm going a little bit slower on this example, giving you extra steps, so that way we can take this simpler example and correlate it to rationals, where we have polynomials. So let's try this out one more time. So let's say we have something that's a little bit more challenging. Let's say we have 3x divided by 6x squared. Now what does that mean? Well, that means we have 3 times x divided by 6 times x times x. Well, what does that mean? That means we have 3 times x divided by 2 times 3 times x times x. And what does that mean? Well, that means we have a 3 divided by 3, and we have an x divided by x, and we have a 2 in the denominator and an extra x in the denominator. So all I did, you guys can't see, I apologize. All I did in this example from here to here is I rearranged my numbers. 2 times 3 is still the same thing as 3 times 2. X times x is still x times x. So I just rearranged it. So now we can see we have a 3 divided by 3. We have an x divided by x. Now this doesn't just cancel out. Cancel out is not an actual mathematical term. So what we do is we divide out. We have 3 divided by 3, and we have x divided by x, and we have, I'm going to put a placeholder of 1 over 2x. So what does that happen? 3 divided by 3 is 1. X divided by x is 1. So in reality, we have 1 times 1 times 1 over 2x. Well, 1 times 1 times 1 is just 1. So you have 1 over 2x as our answer. Now, eventually, the more you do these, the more you're going to see things, and you can go a little bit faster on your simplification. So let's talk about bubbles. When you have a bubble is parentheses, binomials, or a polynomial, something that has parentheses. So here's your first rational expression, and we have this in factored form. So you notice factored form is when you have bubbles. So when you have it in factored form, you get to see already that you have 2 of the same bubbles. Now this is extremely important. The bubbles must match. Okay, they must match identically. So what you really have is x minus 3 bubble divided by x minus 3 bubble times x plus 2 over or divided by x plus 1. So you notice that, the light turned off. Then you notice that you have a bubble divided by a bubble. Those are same things. So just like when we had 3 divided by 3 and x divided by x, x minus 3 divided by x minus 3, because these are the same things, this is just 1. So we have 1 times x plus 2, and we have 1 times x plus 1. So our final answer is x plus 2 divided by x plus 1 simplified. Now we are not talking about any excluded values, so values that x cannot be. We're going to do that later. Let's do one more example. I'm going to shift this up. Let's do one again. And this time, let's try to factor. So let's do a bubble of x plus 5, x squared minus 25. So this is our first time that we need to factor. So when we are talking about bubbles or parentheses, if you have something like x plus 5, it does have a grouping, it does have parentheses around it. Mathematicians are lazy, so you won't see it, so go ahead and place it there. Notice in the denominator, we do have an exponent of 2, which means we have to factor. It's not linear, that means it has to factor. So we have the difference of squares in the denominator. So what we end up having is x plus 5 in the numerator, and this is where your factoring really shows and shines. If you don't know how to factor yet, you need to come seek out assistance, because this is all about factoring. So we have an x plus 5 and an x minus 5. Here you notice immediately that you have bubbles that are the same. We have an x plus 5 and an x plus 5. We are going to divide that out, which gives us a big 1. So we have 1 over 1 times x minus 5, which means we have 1 over x minus 5. Okay. Now I did put parentheses around this x minus 5. You don't have to. You can just leave it as just x minus 5. Okay, now let's talk about excluded values. So excluded values are values, so you have your numerator, you have your denominator. We are focusing excluded values on denominators only, and we want roots or zeros that make the denominator zero. Recall that in a fraction, you can have a number, letter, anything in the numerator. But if you have anything in the denominator that's a 0, this is equal to an undefined. Because 0 times anything is 0. So you cannot have a number or a letter or anything divided by 0. That is undefined. So how do we find the excluded values? You are going to, step number 1, factor your numerator and denominator. Once things are factored, immediately after you factor, you're going to state your excluded values. And you're going to place them in an answer box. Because otherwise you're going to forget. Take your denominator factors. And just like we did with polynomials, you're going to solve for your roots. And these are going to be your x values. When you solve for your roots or your zeros, you're saying, hey, if I use this x value into this factor, it will make that bubble 0. And if we have only multiplication, anything times 0 is 0. And you're going to state your excluded values as x cannot equal blank. So you're going to have your answer as x cannot equal blank. So this is in addition to you simplifying. So let's go ahead and take a look back at our original equations. So anytime you have an x value right here, you are going to identify what your excluded values are in the denominator. So you're only going to look into the denominators. So we're only looking at this guy, we're only looking at this guy, we're only looking at this guy. Now, if you have like an x squared here, you can wait until you get to factored form, but notice you just have x. So you can do this once or you can do it twice, it's going to be the same thing. So x is equal to 0, right? If I plug in 0 into x, here's my thinking bubble, 6 times 0 squared is 0. However, the denominator cannot equal that 0. So what will happen is the answer does not exist, but we're saying it does exist. So as part of our answer, we're saying x cannot equal 0. It's not this 0, it's when we plug it in, that x value cannot be 0 because the denominator will be 0. Let's try this again on the example number 2 or 3. So on this example here, notice we are given factored form. So you're going to set each one of these bubbles equal to 0 and solve. So you're going to say, here's a thinking bubble. X minus 3 is equal to 0. X plus 1 is equal to 0. So x equals 3 and x equals negative 1. When you plug in 3 minus 3 is 0. Anything times 0 is 0. When you plug in a negative 1 plus 1 is 0. Anything times 0 is 0. So part of this answer here is x cannot equal 3 and negative 1. Let's do this one right here. Notice that x squared minus 25 is not the factored form. We don't want that. We're going to go here where we have factored, and we're going to set the x plus 5 equal to 0 and x minus 5 equal to 0. Again, I'm going to put this in a thinking bubble. We're going to subtract and add 5. So x is equal to negative 5, x is equal to positive 5, which means that x cannot be negative 5, nor can it be 5, otherwise it will make it 0. Now, if you notice this negative 5, if you plug in negative 5 minus 5 is not 0 for this bubble right here, and that's okay. Because we were able to simplify things, there are hidden bubbles that you are unable to see that still cannot make things happen, still do not exist. So even though if you plug in negative 5 here, this denominator is not 0. However, if we go back into our steps, it does make this bubble, this x plus 5, 0, so it does not exist. All right, beautiful people, that is it for this video. Thank you so much for watching. Take care. Bye.